let's have a thought experiment. What if there was no moon? And what I mean by that, what if there was never a moon? It would have devastating effects on this earth and on our life. We're going to talk about that. Secondly, we're going to talk about interesting things to know about the moon. And third, we're going to talk about one of the most amazing events that has occurred throughout history, will occur throughout generations to come. It's the most dramatic physical event you can imagine, of extreme light, extreme dark, and I'm talking about the total solar eclipse, which occurs here in Dallas, April 8th. So we're going to talk about that. So let's get back to what if there is no moon? Now think about the moon exerts this gravitational pull on the earth. If there were no moon, what would happen to our tides? The tides would not go completely away. The moon provides 60% of our tidal waves, the sun 40%. But it would seriously change the movement of the water around the earth. And not only that, but the moon that exerts this pull creates a bulge of water around the middle of the earth. Think about that. If there were no moon, that water would be dispersed, less around the middle and more to the north and south polar caps. What would that do to our coastlines? Now here's something really interesting. If we did not have tidal waves like we do now, when you're cooking, you stir your soup, right? Why do you do that? To distribute the heat. If we did not have those tidal waves, can you imagine that we would not have the distribution of the heat like we do now? We would have extreme climate exaggeration, much colder on the poles and much warmer around the equator. So just the moon's effect, its gravitational pull, causing those tidal tides each day, twice a day, creates a huge difference for our life here on this planet. How about the spin of the earth? Did you know that that same gravitational pull creates drag on the spin? And our earth is gradually slowing down. 60 million years ago, when the dinosaurs were here, guess how long our days were? 22 hours. So in the last 60 million years, we have gained 2 hours in the length of our day, because each year that drag of that gravity from the moon slows the earth down by a few milliseconds. Over time it adds up. So astrophysicists say if we did not have the moon, the earth would be spinning at 4 to 6 times the rate that it now spins. Now think about that effect on climate, temperature, storms, etc. It would wreak havoc and make life actually impossible to live on this earth. Now let's talk about something interesting, a third effect of the moon and the stability that it creates with that gravity. Now hang in with me here. I'm going to get a little technical. The earth goes around the sun in an elliptical orbit. Okay? Now imagine that you can create a geometric plane based on the path of that ellipse. Now if you take a perpendicular line to that orbital plane and then set it off 23.5 degrees, that's the tilt of our Earth. And that's what creates the seasons, of course, going around the sun. Why is that tilt, or what they call the obliquity, why is that so stable? It's stable because of the moon. If the moon were not there, we would be like Mars. Mars has no moon. So what happens is Mars flip-flops between 15 and 45 degrees. Imagine what that does to our climate, or what it would do to our climate. You would have the Earth at certain times with the North Pole really facing the sun, and there would be extreme heat. The South Pole would be extremely cold for 6 months out of the year. Vice versa, when the Earth is on the other side of its orbital path. So the gravity that the moon exerts on the Earth has actually created an environment of stability for us to actually have life. So let's talk about some other interesting facts about the moon. You can tell I'm celebrating the moon, so we get ready for April 8th, okay? How was it created? Well, about 4.5 billion years ago, or 30 million years into the life from 4.5 billion years ago, the creation of our solar system, there was this planetary mass the size of Mars that came and hit the Earth. Okay? It shot off and created the moon. It took part of the molten mantle of the Earth with it. So the moon is part Earth and part whatever this planetary mass was. And it set this moon into orbit. So let's talk about the moon's orbit. The moon, of course, goes around the Earth. Now here's something really interesting. Its orbit is nearly, but not quite, the same as the Earth's orbit around the sun. Remember I talked about that orbital plane. The moon goes around the Earth 5 degrees off of the Earth's orbital plane around the sun, okay? So it's not quite the same, it's just slightly off, and that's an important fact to think about when we consider the solar eclipse. How long does it take for the moon to go around the Earth?
30 days.
29.5 days, that's right, okay? Close. How long does it take for the moon itself to rotate on its axis? 29.5 days. It's exactly the same. It's called tidal synchronicity. The moon's face always is the same facing the Earth, right? We always see the same side of the moon. So it rotates on itself at the same speed that it goes around the Earth. That's called synchronicity. Kind of interesting thing to know. Now, the moon is 400 times closer to the Earth than the sun. It's also 400 times smaller than the sun. That equivalence, you'll notice when you watch the solar eclipse, it makes the moon look like the same size as the sun. Something to think about. These 9 minutes go by really quickly. April 8th, the solar eclipse, 12:23. Have your glasses ready. The entire total eclipse occurs at 1:40 p.m. The next time this occurs in Dallas is 300 years from now.
Wow, wonderful. Thanks, this wonderful and educational speech. Thanks, Regan. Okay, let's see how it work. Let's see how it work. 这一次 Eclipse 日全食 Total Eclipse 4分钟在 Plano, Texas 欢迎大家来看这段影片。我把太阳遮住了，4分钟偏暗。然后看它出来了。对不起，我们现场很多人讲话。哇哦，这个就是有没有很惊奇？Total Solar Total Eclipse 月全食，谢谢大家今天观赏 BonBon Solar Eclipse。